Now today we start fifth chapter straight line from first paper. So see the first definition of locus. A set of points in a plane which satisfy certain geometrical condition or conditions is called a locus. That means in short we can say collection of points satisfying some geometrical condition or conditions is a locus. So we write here set of locus generally denoted by capital L. You can use any letter for the set of points. So here for locus we denote the set by capital L. So it is the set of those point. So we write here L is the set of those point. Here we consider that point as P. So we write here L is the set of point P such that P is a point in plane and P satisfies given geometrical condition. So see here this point P is called a representative of all points in L. So for this set L, or we can say for the locus L, P is the representative of all points in set L. L is called the locus of point P. Locus is a set of points, so we call locus is a set of points. The locus can also be described as the root of a point which moves while satisfying required conditions. So best example here planet in solar system. So with the help of some example we discuss this topic. So see here the perpendicular bisector of segment AB is the set. So we denote the set of points on the perpendicular bisector for segment AB. So we denote the locus M. So we write here M is the set of those point P such that P is a point such that PA equals to PB. That means all the points on a perpendicular bisector are equidistant from the end points A and B. So we write here PA equals to PB. Then second example, the bisector of angle AOB is the set. So we write here D as the locus. It is the set of those point P such that P is a point such that P is equidistant from OA and OB. Or we write here in angular form, it is the set of those point P such that angle POA equals to angle POB. So see here with the help of diagram. Here we write this first condition, P is the point such that P is equidistant from OA and OB. So when we draw perpendicular from this point P to this ray OA and OB, then the perpendicular on that array are the equidistance, that is here PA equals to PB. If we consider this point as P and this point as A and this point as B, so PA equals to PB, or in angular form we say this angle POA, that is POA is equals to angle POB. Then one another example, the circle with center O and radius 4 is the set. So we denote the set of those points which are at a distance 4 from fixed point O. So here we write OP equals to 4, that is a radius 4. So the diagram like this. So if we consider any point on the circle of circumference, that point is equidistant from fixed point O. So the circle is a best example of locus, the collection of points which are equidistant from fixed point. So the fixed point we always call center, and the distance called a radius of that circle. Then equation of locus. So see here, if the set of points whose coordinates satisfy a certain equation in x and y is the same as the set of points on a locus, then the equation is said to be the equation of locus. So likewise, the set of points on the locus, if we consider the equation and that equation satisfied by coordinate x and y, then that equation is called equation of locus. So see here, for example, we know that the y coordinate of every point on x axis is 0. So in class 10 we discuss equation of x axis, equation of y axis. We know that equation of x axis is y equals to 0 because for every point on x axis y coordinate is 0, and this is true for point on the x axis only, and this condition, that is specific condition, so we write here this is true for points on the x axis only. Therefore the equation of x axis is y equals to 0. That means equation of x axis is the equation of locus because it satisfies one specific condition, that is every point on x axis has y coordinate 0. Then second example, L is the set of those P such that OP equals to 4, that means circle having radius 4. Find the equation of L. Here we have to find the equation of locus. So we draw here a rough diagram. Here we consider any point P on the circumference which is at equidistance or which is at a distance 4 unit from fixed point O. So by using distance formula, so we write here in solution, L is the locus of point in the plane which are at 4 unit distance from the origin. So here L is the locus of point in a plane which are at a 4 unit distance from the origin. That means it is the collection of those points which are at a distance 4 unit from this fixed point O, that is from origin O. Let P of xy be any point on the locus L. So here we consider any point, that is P, on this locus L. So by distance formula we say OP equals to 4. So squaring on both sides we get OP square equals to 16. So we write here distance formula for OP. So if we consider this O as x1 y1 and P as x2 y2, so we have the formula x2 minus x1 bracket square plus y2 minus y1 bracket square. So we apply here distance formula. So we write here x minus 0 bracket square, then y minus 0 bracket square. So here we get x minus 0 as x square, y minus 0 as y square. So x square plus y square equals to 16 is the equation of locus. So this is standard equation of circle. When center at origin, then the equation called standard equation of circle. So this is the equation of locus EL. The locus is to be a circle. Then one more example. Find the equation of the locus of points which are equidistant from A of minus 30 and B of 30. Identify the locus. So here we have to find the equation of locus of points which are equidistant from these given 2 points having coordinate minus 30 and plus 30, and we have to identify the locus. So we first take one point here. So write in solution, let P of xy be any point on the required locus. Now here P is equidistant from A and B. So we write here condition PA equals to PB. So squaring on both sides, we write here PA square equals to PB square. Now apply the distance formula for PA. So we write here x plus 3 bracket square minus plus y minus 0 bracket square. Here coordinate of P we consider as x2 y2 and coordinate of A we consider as x1 y1. So we write here x2 minus x1 bracket square plus y2 minus y1 bracket square, that is x minus, so minus minus get plus, so write x plus 3 bracket square plus y2 minus y1, so we write here y minus 0. Then for right hand side, here we consider again x2 y2 as xy and x1 y1 as coordinate of point B. So we write here x minus 3 then y minus 0. So simplifying this, we apply the a plus b bracket square formula for first bracket. So write x square plus 6x plus 9 expansion of first bracket, y minus 0 we write y square. Then for this right hand side we simplify this, so write x square minus 6x plus 9, that is simplification of first bracket, plus y minus 0 we write y square. So this plus y square minus y square get cancel, this plus 9 get cancel, this x square get cancel. So we get here minus 6 and this plus 6 left only. So 6 plus 6 we get 12, so write 12x. So we use here concept AB equals to 0 only when A equals to 0 or B equals to 0 or both are 0, but we know that 12 is not 0, that means x equals to 0. And this is equation of y axis, that means here y axis is the perpendicular bisector of the seg AB. So the locus is the y axis